Louisiana. It's just amazing. You can't see it now, but if you stepped out of the door, Tiger Stadium would be there. It's a place where dreams go to die for people. But it's also a place of teamwork, an amazing place of teamwork. And here at LSU, we're in the business of winning teams. And so, Andy, you're now a part of that, and everybody that's a part of FUEL. This is a winning team. So thank you all for being here. Have a great panel, and look forward to celebrating with you a little further later today.
Awesome. Thank you, President Tate. Thanks for being here, and thanks for introducing our panel. For those of you that don't know me, I'm Andrew Moss. I'm the Associate Vice President for Research over Innovation and Ecosystem Development at Manage Innovation Park down here. And as President Tate said, I'm also the principal investigator. I can look back here at Sam Bentley, who was the Vice President for Research at the time, and he sent me an email and said, Andy, you're going to be the PI on this project. And I was like, I guess I'm going to be the PI on this project. So it's great to have everybody here, and it's great to have the panelists here. This is a historic event for the state of Louisiana, for our partners, for the university, and really for energy in our state. What I'd like to do is just set a little bit of a stage here. This, as President Tate mentioned, this has been an 18-month-long process from when we submitted our first white paper to when we were asked to come in and put in our full proposal, to when we put in the full proposal in January of last year, to when we were invited to a virtual site visit in June of last year, to when we were invited to an in-person site visit in August, and NSF sent 13 panel reviewers. And if you know anything about the National Science Foundation, that is unheard of. To when I got an email in October saying, hey, your project is being recommended for funding, but you can't tell anybody. And I was like, what? I can't. So we have been working feverishly behind the scenes, and in January it was fully announced. So we're glad that we have all of our media here, media friends, all of our industry partner friends, to be able to celebrate this and explain what this means for the state of Louisiana, why the federal government thinks that this is an important investment to make in our state at this point in time. Our panelists, going to introduce, we have Erwin Gianchandani, close enough. Justina, so Erwin's with NSF, Justina Gallegos with the Office of Science and Technology Policy at the White House, Nigel Jenvey from Baker Hughes, Erik Oswald from ExxonMobil, and we have Nguyen, who's from Shell, and we have John Flake, who is a chemical engineering faculty at LSU. So I'm going to turn the time over to Justina to say a few words, and Erwin to sort of set the stage from the federal policy level, and then we'll just jump right into some Q&As. Is that okay? Is that okay with you guys? And we will have extra microphones if somebody wants to ask questions. I have a few already teed up for these guys, but we'll go from there. So Justina.
Great. Well, thank you. As mentioned, I'm Justina Gallegos, the Deputy White House Science and Technology Advisor, and it is a pleasure to be here. We are here to share our excitement about Louisiana's selection as a regional innovation engine and really set up Louisiana to be a driver of the clean energy economy of America's future. The Baton Rouge engine embodies the president's vision of an American economy where global competitiveness is driven not by outsourcing our talent and expertise, but by investing right here in the heart of communities like Baton Rouge, who will drive our country and economy forward. For decades, the U.S. exported jobs and imported products, while other countries surpassed us in critical sectors like infrastructure, like clean energy, like semiconductors, and like biotech. But thanks to President Biden's Investing in America agenda, including a historic suite of legislation across the bipartisan infrastructure law, the CHIPS and Science Act, the Inflation Reduction Act, that landscape is changing in real time. And that's incredibly exciting. The president's Investing in America agenda is mobilizing historic levels of new private sector investment here in the US. We are tracking over $500 billion new private sector investment here in the US and counting. That is bringing manufacturing back to America after decades of offshoring and creating new good paying jobs, including union jobs and jobs that don't require a college degree. The President's Investing in America agenda is rebuilding our roads and bridges using materials made here in America, built by American workers, and it is transforming our country for the better, reaching communities in every corner of the US, which brings us to Louisiana. The CHIPS and Science Act established the National Science Foundation's regional innovation engines, which build on regions' scientific and technological expertise and strengths to establish new industries and workforces, creating more possibilities for Americans to participate in the 21st century economy without needing to leave their communities. Again, this is capturing the future without needing to leave your community. The NSF engines bring together private industry, venture capital, state and local governments, institutions of higher education, including community colleges and local technical schools, labor unions, tribal communities, and nonprofit organizations to transform their communities and regions over the next decade. This program is critical to the President's economic vision of supporting regional economies and bringing communities together to tackle economic and science challenges that we all need to address together and bolstering industries of the future, which is why we are so excited about what is happening here in Baton Rouge. And so with that, I will say congratulations on this incredible award, and I will turn it over to my colleague Erwin from NSF. Thank you.
Thanks very much, Justina, and good afternoon, everybody. And let me just first start by saying congratulations. Congratulations to Andy. Congratulations to the entire team that you have pulled together, and really congratulations to the entire state of Louisiana. As Justina said, what we're talking about here is truly game-changing and transformational. We hope it will be game-changing and transformational for the state of Louisiana, but at the end of the day, we also hope it will be game-changing and transformational for the nation as a whole going forward. We're here today to celebrate, I think, a significant investment into Louisiana. We're here to celebrate the work that Andy and everyone else put to get to this point. But we're also here to think about what comes next, right? This is just the beginning of, I think, what will be an even longer journey than the last 18 months of actually delivering on the promise that this engine brings forward with regard to really being transformational for this state and for this nation. Now, the NSF Engines program, as my colleague Justina mentioned, really is about trying to be able to invest in regions and communities that we have left behind as a nation over the course of the last many decades. We've seen technological booms. We've seen that technological boom result in economic growth and pay dividends for lots of folks, but it hasn't done so equitably across the country. And so each of the 10 NSF engines that we ultimately selected, as Justina said, comprises this broad and multi-sector coalition. And our goal is for each engine to ultimately be able to put its region on the map as a national leader and potentially a global leader in a particular technological space, as well as in a particular space that contributes to economic growth and societal impact. And in this case, it's about that energy transition that Andy and his team have really helped to try to galvanize and orchestrate over the last several months and over the last several years, even prior to the Engines program being announced. Here's something significant about the Engines program. We announced $150 million worth of investment back at the end of January, together with the White House, in these 10 regions across the US. That $150 million of investment is already being matched by more than $350 million in contributions from state and local governments, from private sector interests, from nonprofits, and so forth. A 2-to-1 match on your taxpayer dollars, because that's how significant these investments are to the states, to the localities, and to the private sector interests as well. And we do hope to see more of that as we go forward as well. Ultimately, more than $530 million just in this initial outlay for the first couple of years, and potentially upwards of $1.6 billion over 10 years across these 10 engines. That is the single broadest large-scale investment, to our knowledge, in place-based research and innovation and workforce development and talent creation in the nation's history, going back almost 150 years to the Land Grants Act that established a number of universities all across this nation. But this investment, in our view, goes beyond simply the research that I think this panel is going to talk about this afternoon. As Justina said, it's also about it's not only about advancing technologies and giving rise to solutions to some of our pressing societal and economic challenges. It's also about trying to be able to grow the workforce of today and tomorrow. I think for too long, we've had a situation where we've simply not engaged the full spectrum of talent, from geographic diversity, from demographic diversity, and so forth, in STEM, in science, technology, engineering, mathematics, and in the STEM-driven jobs of today and tomorrow. And so here's an opportunity for us to really put the spotlight on what are the pathways that allow us to meet people where they are, and really to be able to engage that diverse talent, those diverse geographic locations, in the ability to be able to become a part of that STEM-driven economy and put folks on trajectories, on pathways that lead to high quality, good paying jobs of today and tomorrow as well. That will not only put themselves in a good place when it comes to their own livelihoods, but will also allow them to be able to generate these new technologies that will ensure that the US remains the world's leader in these technological areas from the here and now and into the future as well. So this particular engine was not selected by accident. This was an intensely competitive process. My colleague, Becky Shearman, a program officer for this effort, and I were talking about this just before this panel. We did more of a rigorous review than I am familiar with on most projects that we have at the National Science Foundation over the course of the last 18 months. We looked at the 50 plus partners who've come together. We looked at the research goals. We looked at the workforce ambitions. We looked at the infrastructure that this project will be able to make available. And ultimately, this engine, I think, is a great example of how a region can come together and coalesce around a particular topic space that offers it the shared desire to address key challenges and really be able to drive home not only solutions, but real job creation and upward mobility in terms of the socioeconomic ladder going forward as well. So I have to say that the NSF Engines program, at the end of the day, our goal from the very start was to acknowledge that American ingenuity starts locally, and it's stronger when there are more pathways for workers, for startups, for entrepreneurs, and for aspiring leaders of today and tomorrow to participate and shape the innovation economy in their own backyard, as Justina said. And so we at NSF are really proud to be a part of this moment. We are proud to be a part of the Louisiana ecosystem and to really have this engine, this fuel engine, be a place where American ingenuity and opportunity will, no pun intended, fuel prosperity for decades to come. So congratulations again, Andy. Congratulations to everybody in this room and to the entire state of Louisiana. And I look forward to the conversation.
Wonderful. Thank you for the introductions, and I appreciate the perspectives. While we have a lot of work in front of us, we also have some visions of what we're hoping to accomplish with this. And so we have with us 3 of our industry partners. And what I would like to start with for each of them is, can you each share your view of energy transition and how it impacts your company? You can talk about it globally, but I'd really like if you can focus on the impact in the state of Louisiana. So Dai, can we start with you down at the end?
Sure. This is on? Yeah. Okay. I really appreciate our opportunity to come and participate and be part of this. I think when I think about where we are in Louisiana, I have to go back. That Shell's been in Louisiana almost 100 years now. And when we think about the energy transition, it gives us an opportunity to maybe secure the next 100 years with Louisiana. The opportunity right now is to use the energy transition with some of our businesses and our sites in Louisiana. Specifically, we utilize our energy and chemical parks as sort of the integrator for the opportunities. And specifically, that's in our Norco facilities, our Geismar and our Convent facilities, which is actually hoping to be our hub to grow when we think about the new technology development there. So really exciting to be part of that and to hopefully secure the next 100 years here as we make the energy transition. Probably the biggest exciting part for us is when we think about our Powering Progress strategy, there's a Powering Lives. And the part that's talking about workforce development, such a huge part of essentially what we've done, Shell's done in Louisiana. Certainly I grew up, even an immigrant, grew up in New Orleans, and yes, I didn't go to LSU, but close enough in Louisiana. But really a great opportunity to come back and lead some of the business and to be participating in such an opportunity. Now, for Shell, one of the big things is if Louisiana is a country, and for us, we know that is a country, but in Shell, if Louisiana country is our third largest country when we think about our investments and our base. So I think you can certainly say we're here to stay, and we hopefully to be part of Louisiana's growth in the future.
Wonderful. Thank you, Dai. Erik, talk about this with respect to how this is perceived or viewed on the ExxonMobil side.
Well, similarly, ExxonMobil has a long history here in Louisiana, and very much plan to continue that along, and grow that future. I think most people think about the energy transition in three broad sectors. There's transportation and power, where we get our electrons from. We hear a lot about that in the media. Those are commonly reported on. But a third and extremely important part of the energy transition is decarbonizing the industrial sector. And this is the part of the economy that delivers all kinds of products, whether it's cement or plastics or fertilizer, all kinds of things that we know we have to have in society, and we don't really have a better way to make them. And that has to be decarbonized over the coming decades. And so when ExxonMobil looks at the energy transition and it looks at its set of expertise and tools, that's an arena that it feels like it can make real contributions in. And two of the primary tools for working the decarbonization of those sectors are CCS, carbon capture and storage, and hydrogen, broadly considered the hydrogen economy. And there's two specific example projects that are already up and running and underway that illustrate that. At Baytown, we're designing and getting ready to build what will be the largest blue hydrogen facility in the world. It'll deliver something like 1 billion cubic feet a day of clean hydrogen, and that can be used over the Gulf Coast to help decarbonize the industrial sector. We expect to take FID on that decision here later this year. And then on CCS, you've probably heard of a recent acquisition we've made with Denbury, which has a very large, the largest CO2 pipeline system in the United States that traverses from Mississippi to Texas, much of which lies in Louisiana. And this becomes like a fundamental linchpin for decarbonizing the Louisiana and heavy industrial sector. So you can think of that as like a large tank, and we can remove man-made CO2, put it into that tank, and then move those emissions to sequestration sites anywhere along that pipeline system and sequester it permanently in the very advantageous geology of the Louisiana and Gulf Coast region for CCS. So we're very excited about Louisiana's role in the energy transition, and the Gulf Coast. It has many huge advantages that we don't see internationally when we look at these businesses. The confluence of geography and geology and heavy industry collected in one location really positions Louisiana to be economically extremely competitive in the future for decarbonized products.
Wonderful. Thank you, Erik. And Nigel, for Baker Hughes, what does this mean for your company on the R&D and the workforce and sort of the tech development side of things?
Thank you. Thanks, Andy. Really appreciate your invitation to be a part of this broader partnership. I think it's a great opportunity for Baker Hughes and to work with the 50 other partners that are part of the FUEL partnership, including some of our customers, of course, here at the table as well. And I think as I think about the FUEL partnership, empowering, expanding the energy workforce, of course, that's really important. LSU and the other universities here in Louisiana have always been a great way for us to access talent. and bring that talent out and through into the energy industry, and to then train them and bring them into the workforce. So I think that part of what we're going to do here is going to be really, really important, and we're really looking forward to working on that, but also accelerating energy innovation and the R&D and the ideas that really can just spring up from anywhere. Anybody can have an idea, and they need somebody to listen to and some other people to help them mature that idea into and bring it forward. But when it comes to the energy transition, that's basically a global $1 to $3 trillion new marketplace. And that's really how we think about it at Baker Hughes, and all of the capabilities we have with our technology and our people. How do we then address this new marketplace, which is the energy transition, as well as, of course, sustaining the energy infrastructure that we have today? But how do we also lean in and move into the energy transition? And indeed, Louisiana is the center of course, industry and the infrastructure that we have here in pipes, but the people as well. And the people are really important for us to be able to work with them, work with their ideas from coming out of high school and the community colleges, and working basically with them and growing their ideas into fruition and bringing those into the marketplace.
Wonderful. Thank you, Nigel. And so technically, a lot of people are wondering, well, what are the areas you're going to work in? Well, so we do have some technical thrusts, one of those being CCUS, so carbon capture, utilization, and sequestration. CO2 as a feedstock. So you heard some conversations about CO2 and putting it into pipelines. The hydrogen economy. So what does that mean, and why would we be concerned about a hydrogen economy? Water use and reuse. One of the values that comes to Louisiana is that we're sitting on the largest source of fresh water in North America, and that is very valuable for our industry sectors, both as a transportation mode, but also for the technical side of things. And then we are also focusing on two other areas, one of them being our built infrastructure, the capability of our built infrastructure to last for another 100 years. What do we need to do for that built infrastructure? And then the policy and the economics behind carbon capture, our carbon economy, and some of this energy transition. So I want to go to John Flake down at the end. And I'm not going to let you get super technical, but I want you to talk a little bit about how does the technology here change energy transition, and why is this critical for our partners and our research in enterprises at the universities?
Yeah, that's a good question. So it's a little complicated. Some people call it the energy transition vortex because we use different words to talk about the same thing, and it gets sort of complicated. So I'll try to share my perspective. I see it as first sequestration is the first step, and some people say blue hydrogen, but they're really talking about sequestration there. And then after sequestration, I see electrification. So industries in Louisiana can continue to use the same plants we do now, and we just add on a carbon capture unit, CO2 pipelines, and sequestration, and we can continue business as usual, but with zero CO2 emissions. We can sequester that CO2. But long term, the ideal is to decarbonize. And I don't like the word decarbonize. I always say that some of my best friends are made out of carbon. So I really think carbon's a wonderful thing. I enjoy carbon. Yeah. So I don't say decarbonization, I call it electrification. So the idea there is that we move away from fossil fuels altogether and we use renewables and also nuclear. Nuclear is a great way to produce electricity, and it doesn't have the intermittency problems, and there's zero CO2 emissions. But we can transition to using electrical energy to make all the products that we make today. So a lot of people don't know this, but Louisiana is like #1 in the US in making ammonia. That's the critical ingredient in fertilizer. It's 3% of your body. I tell my daughter that her brown eyes didn't come from me, they came from Donaldsonville. Because that's where the ammonia came from that made up the amino acids that are in her DNA. So it's a critical part of life, and Louisiana plays a huge role in that. It's not just products, it's the food we eat. even the cereal that the corn needed the ammonia to grow, the package that it's in is ethylene. That came from Louisiana. But we can make all of those products without emitting so much CO2. We can make the world's ammonia. We can make ethylene, and you don't have to use CO2, or you don't have to emit CO2. In fact, you can use CO2 as the feedstock to make these carbon products. So in my lab, that's what we're focusing on, is that we take CO2 and water, and it's the reverse of the combustion reaction. So instead of getting heat out, we put electricity in, and we can convert that CO2 and water back into products like ethanol, ethylene, acetate, acetic acid. I'm getting too technical.
I was about to stop you.
But the ethylene is the common building block for so many chemicals. It's your shampoo, your detergent. So many of the products that you buy every day come from things like ethylene.
Wonderful. Thanks, John. So Justina, when you guys talk about this at the White House Office of Science and Technology Policy, what is the critical discussion around Louisiana, and Louisiana being this epicenter for the energy transition? And your microphone's off.
Sure. So Secretary Yellen at the Department of Treasury shared that through 2050, each year, the energy transition will involve upwards of $3 trillion being mobilized globally. And so when we think about that amount of money through 2050, we are incredibly excited about the opportunities for our country and regions across our country to be driving that transition. And I think that was part and parcel of the impetus behind the Engines program, but particularly I would love to hear more from Erwin on the actual selection, but making sure that America's energy future is secure and resilient and reliable, and also capturing the future of where those technologies are going. We know that we can build all of those technologies here in America, and we want that to happen in places where we are already building from strength, and we know that that strength is here in Louisiana. And that was, I'm sure, part of this selection, which we were blind to, but those principles of building from strength were critical, and we know that all of that exists, both here in this room, here at this table, but also in the broader community, which I think has been mentioned, but we are so excited about.
Absolutely, and I'll turn it over to Erwin here in a second, but Erwin said something in his opening remarks about place-based economic growth. And so I see what the NSF is doing here as a big experiment to see if they can move the needle in regions that have historically been under iterated on the innovation cycles. And so, Erwin, when you guys have the conversations about Louisiana and you're talking about this at the highest levels of the National Science Foundation, what was it that intrigued you about the state of Louisiana and our proposal?
Yeah, so Andy, let me first start by doubling down on what you said about place-based innovation. That is part and parcel what the Engines program is all about. And in many ways, the Engines program is it's not only an experiment unto itself, it's also an experiment for the National Science Foundation. So how many of you are academic faculty members in the room? Do we have any researchers in the room? There you go, quite a few, right? Mm-hmm. I think most of you would probably say this is not the type of program that you see out of NSF, right? For the most part, the National Science Foundation is known for the basic foundational research that we support in a whole host of science and engineering disciplines, from biology to chemistry to computer science and beyond. What we're doing with the Engines program is we're saying we care about that foundational research every bit. But we also care about use-inspired research. We care about the real-world use cases that can serve to motivate the R&D that we're pursuing. We also care about that entire end-to-end ecosystem that you need to construct, thinking about not just the foundational science, not just the real-world use cases that can motivate those, but how do you then prototype and pilot? How do you experiment in that real-world context to be able to translate some of the key insights into practice on a day-to-day basis, right? And so when we talk about place-based innovation, there are examples across the country that we point to, right? There are places like Silicon Valley or Kendall Square outside of Boston and Cambridge, right? Where you have a constellation of folks who've come together, whether it be academic researchers or private industry or state or local governments, to really catapult and create this sort of ecosystem that's constantly churning out new technologies in the case of Silicon Valley, or potentially new biomedical products in the case of Boston and Kendall Square. We're trying to do something similar to what you said, Andy. We're trying to do something similar in other parts of the nation that you said it in one way. I'll just be very candid. We have not invested in over the course of many decades to the extent that we could or to the extent that we should. But there's intellectual capacity, there's geographic strength, there are the stakeholders who are there, whether it be academic researchers or the private sector or others, who can come together, and all of that can coalesce around a particular movement, if you will, to make that particular region into the nation's leader, just like we see in these other parts of the country today. And so when we're looking at the proposal that you all submitted, and it was discussed at the highest levels of the National Science Foundation, my boss, the director of NSF, couldn't be here today, but he sends his greetings, and this is a project that he's super excited about as well, right? You know, when we talked about it, we looked at the coalition that you brought together. You have world-leading oil and gas companies in the room. You have the state of Louisiana that has put forward a commitment toward this project. You have the universities, not just LSU, but a broad coalition of pretty much every university, community college, technical school in this state that have come together, right? And collectively all agree that there's a unified, shared challenge that we face. And we have the resources and that intellectual capital to be able to potentially move the needle forward with regard to that challenge. And, you know, when I talk about the Engines program, I talk about, for a given region, what is your competitive advantage vis-a-vis other regions across the US, right? And I think that it's going to be hard to argue with the fact that Louisiana is a leader when it comes to this nation's energy system. And we need to be thinking about, if we're thinking about energy transitions and want to make a meaningful commitment in that regard, there are few better places than Louisiana to be able to try to foster that and engineer that going forward. And so I think that that is sort of what we saw in this particular proposal, an ability to bring together this broad coalition, focusing on a particular topic space, and then the commitment that, yes, you need that end-to-end research, but you also need to think about the people who are going to become a part of the workforce today and tomorrow, the people who are going to be impacted by this work, and how do you do that in a way that's sustainable for the long term as well, so that, you know, NSF is not going to be here providing funding in perpetuity to this effort, right? That's not success. Success for us is we catalyze it, we serve as the spark plug, and then over time, this engine is so critical to the state of Louisiana and so critical to this region that the region is now investing in this activity in the medium to longer term, beyond what the American taxpayer might do to ensure that position of strength is retained for the US.
Wonderful. Thank you, Erwin. So there's been some reports done around the energy transition workforce and the needs of the workforce in the next 20, 30 years. And some estimates have it as high as an additional $250,000 or 250,000 jobs will be required by the year 2050 to service the energy transition only in Louisiana. So Nigel, talk about how Baker Hughes is working towards that workforce need in your industry and in your company.
I mean, yeah, it's. I mean, there's about the same amount of people in energy in Louisiana today, right?
Yes.
So it's 250,000 today working in energy, and an additional 250,000 by 2050 to work in the energy transition areas too, right?
Correct. Yeah, there's 250,000 approximately currently in energy in Louisiana and the ancillary support services, and recent anticipations would be about another 250,000 required by 2050. So.
Yeah, and it's because the amount of energy, you know, that everybody consumes, you know, is increasing. To reduce emissions, CO2 emissions, that actually also takes energy. To capture CO2 from the atmosphere and to suppress that takes energy. You know, to create hydrogen from water, through electrolysis. That takes a lot of energy. So yes, there's more and more energy that we need to produce, consume, but of course, whilst also reducing those CO2 emissions. So it just takes more energy, more people in order to actually deliver the end result. And so, yeah, it's a really important thing, of course, to focus on the people and where they're coming from, where this workforce for the future really will originate from. Attracting younger people into energy, is a key thing that we're all focused on doing, because of course, I think there's a certain barrier from STEM aspects and the attractiveness of coming into traditional industries rather than new tech and IT, etc. There's definitely a barrier there of perception, I would say. And so, reaching out and I think working with the youth of today and bringing them and educating them as well about energy and the importance of energy and how systemic it is to everything we do in life, to amino acids and shower gels and shampoo and plastics and this table and the carpet, etc. It's not just transport. It's really important to attract that workforce of tomorrow into this industry so we can grow it. It's about sustaining the jobs of today and growing the workforce for the future.
Yeah, that's wonderful. And Erik, how do you guys remain sort of flexible in that workforce space, as some of the jobs that we are going to need don't even exist at this point in time? So how do you build a workforce 10 years out when you may not even know what they're supposed to be doing?
It's a good lens to look at it when you think about technologies and what the energy transition means in terms of technology. Today, we actually know that we have the technology set to start on this. And many of these are very familiar technologies, perhaps applied in slightly different ways or at new scale. CCS being a good example. CCS we've been doing this for decades. There's a lot of experience in the companies. Our companies, moved CO2 around quite a lot, stored it in the earth for long periods of time. But at the scales we're talking about going forward, it'll be something dramatically different. Similarly, hydrogen, there's an enormous hydrogen economy today. Hydrogen's used in all kinds of industrial processes. Companies create hydrogen, usually from methane, and then move it around and use it, but not at the scale that we're talking about going forward. So I think that's something to keep in mind. There's a technology set today that we can confidently apply. It needs to be done well. It needs to be done with operational integrity. We have an experience set that would tell us we can do that if we execute well. We need competent companies involved to execute that well. But the other really exciting thing about the energy transition is we know that we can't get to the end with the technology set that we have today. We know that those things aren't going to be able to carry us by themselves all the way to net zero goals that the country's laid out for itself. And those are going to require whole new technology sets, which I'm sure I don't know what they are. I'm sure that we can kind of imagine what types of things are going to be coming in 20 years. We try to stay on the front end of that. We research very hard. Things like direct air capture are things that we're investing in, trying to kind of anticipate the future, trying to get the costs into a place where society could afford them. But for me, that's one of the most exciting things about embarking on this, is that while you can start down the path because you have the tools in hand to start down the path, you also should know that you don't have the tools to finish the job. And that gets us into heavy investments into technology, heavy investments in workforce development, which this program is a beautiful illustration of. And then I think the final thing that we know that we have to kind of continue that journey is we have to figure out how to make this work in society, in communities. And that means there has to be economic benefit locally. There has to be job growth, business growth associated with these major investments.
Wonderful, thank you. Di, you made a comment about using your facilities here in Louisiana as sort of a test bed for some of these new technologies that might be spinning out. Can you maybe just give me 2 minutes about what that means for Shell and why it's important for Shell leadership to have a place where they can test some of these new technologies?
Yeah, certainly one of our strategies then to get to net zero by 2050 And obviously there's technology that has participating like our partnership with LSU, where essentially scientists are testing new technologies, but at some point you do have to scale it to essentially maybe get to the engine that certainly Erwin's talking about. And I think if you think about what President Tate said was about a winning team. So if we're all working together and we're collaborating faster, and hopefully solutions that come out can go faster from the standpoint of from a laboratory university setting to maybe an industrial scale, and from there allow us to scale up faster as a company and as a whole state. And so I think this is really the power of this whole relationship and this engine that's being created. And certainly we're using similarly with our Convent facility as one of those test cases.
Wonderful, thank you. So we're at time now. What I'd like to do before we wrap up is I just absolutely like to, would be remiss without thanking all of our partners that are here at the table, but also the partners that we weren't able to put 65 people or 65 organizations on our panel. I'd also be remiss without acknowledging the support of our Office of Research and Economic Development, our current VPR, Robert Twilley, who's in the audience with us today, and President Tate, the university, and their support for this initiative, and the LSU Foundation. We do probably have time for one question from the audience. So if there's somebody that has a question in the audience, we're happy to take that, and I'll try to direct it to the right person. Yes, go ahead. Just, do we have a microphone? Oh, we got a microphone coming. Abby has a microphone for you. Yeah.
Good afternoon. I'm Theda Daniels-Race. I'm a professor of electrical and computer engineering here at LSU. And I'll preface my question in that I'm actually an appointee as well to the U.S. Department of Energy's BSAC, or Basic Energy Sciences Advisory Committee. And I see a smile, you know, the Office of Science. That said, I was interested to know, with this marvelous initiative, program, and so forth, as we talked about in BSAC about a month ago, what kind of opportunities do you foresee for maybe interagency interaction across funding agencies and such, which is always a plus? By the way, from New Orleans and used to work at Baytown.
Thank you, Dr. Race.
So awesome question, Dr. Race. And I invite Justina to weigh in as well. Let me say a couple of things about the interagency piece, the interagency collaboration, because I think that that's really, really critical. You know, when we first launched the NSF Engines program, it was almost 21 months ago now. It was in May of 2022 that we launched the program. Almost immediately, because it was such a phase shift in terms of what NSF has historically done and in terms of the significance of this program, almost immediately we had other agencies across the federal government reaching out, expressing an interest in trying to see how could they potentially engage with us, how could they potentially work with us. And I would say that under the leadership of my director, under the leadership of this White House Office of Science and Technology Policy, we have tried to foster some of that dialogue into relationship building and into engagement, meaningful engagement between NSF, the National Science Foundation, and other agencies. In fact, the fact sheet that went out that announced these 10 engines, you will note had a number of agencies that were listed at the bottom of that fact sheet that spoke to real commitments that those agencies are making available to these 10 engines to maximize the chances of success for these engines. It might be access to a test bed. It might be access to expertise. It might be access to future grant provision, right? All of that to try to make available to these 10 engines and tailored, right? So we didn't list every agency in the federal government, right? We listed the ones that were in alignment with the projects that we are funding as part of this portfolio. So there's FUEL here in Louisiana, there's regenerative medicine in North Carolina, for example. There's aerospace and defense in southwestern Texas and southeastern New Mexico. And you'll see that that fact sheet had engagements with agencies like ARPA-H, the Advanced Research Projects Agency for Health, or NASA, for instance, in the context of that engine in the Southwest. So I think that southwestern Texas, southeastern New Mexico. So I think that we've tried to be very diligent and thoughtful about that sort of interagency connection, that we don't just do it for the sake of doing it, but we do it from a place of this is the value add to these engines and to this program, and this is how the engines can potentially harness those resources. So we're really excited about that, and I will say that, again, under this OSTP, under this administration, we've seen a sort of level of engagement across agencies that in my time in Washington is really unprecedented. And I've been at NSF for over 12 years now, or almost 12 years now.
Wonderful. Justina, do you want to answer anything on that? I can move to another question because.
I would love to answer that question.
Okay, go for it.
So thank you, Erwin, and would love to build on that. So President Biden's industrial strategy across bill, CHIPS, and IRA, those huge pieces of legislation, is about strategically investing in America's industrial bases, which we know we have built and innovated incredible technologies. Think of semiconductors. We invented those and then offshored, and unfortunately, those became dangerously concentrated outside of the US. And so when we think about what the specific technology investments across bill, CHIPS, and IRA are going to, they are investing in the technologies and sectors that are going to drive our country forward. And this engines program is the perfect example of that strategy in action, in place, because to your question, that making the most of those investments requires collaboration in a new way, from our university partners to our corporate partners to federal, state, local partners to agency partners, all the way from the labs to, of course, the Office of Science, through the more applied offices, and every part of government. And so all of those industrial bases are going to take immense collaboration from every corner of those regions, but also, of course, federal government as well. And so we are excited about that collaboration happening at every level, and across all the sectors that we are investing in.
Wonderful. And if there's anybody in the room, any university in the state that is going after additional applications for some of these other agencies, we would invite some collaboration on those things. We're happy to help in whatever way we can make connections to the industry partners, to the NSF, to the Office of Science and Technology Policy. Erwin, you were going to say something else? Go for it.
I was just going to add, to our colleague who asked the question, hold us accountable as well, right? So you serve on an advisory committee for the Office of Science, Basic Energy Research. We know our colleagues at Office of Science reasonably well, but you have an opportunity as a member of that advisory committee to encourage continued collaboration of this ilk, of this form, right? And so I would just urge you, and I mean, a program like this and an investment like this, an effort like this, just like Andy, you credited everybody in this room and beyond for the proposal and the success, although everybody should give you a round of applause for getting this project.
You keep saying it's me. It wasn't me, man.
But I think it's also important to acknowledge it takes everybody working together on advisory committees, on boards, and in contexts where you have the opportunity to really emphasize this type of engagement.
So I'd like to open it up to anybody from the media for any questions from the media. Yeah, we have a question over here.
Hello, my name is David Mitchell. I work for the Advocate in Tom's-Picayune. I have a question for the three company executives. It's a two-part question, as usual. First, could each of you identify one specific problem, technological problem that needs to be solved for your individual companies to get to this energy transition? Like how do we do this? Number two, when you're on the other side of this transition in 2050, whoever's still kicking around at that point, will people still be drilling for oil and gas? Or will we have found another way to make the stuff we make from oil and gas today?
I'll jump in.
All right, Erik, you can start.
Yeah. So, David, great question. The first question about new technologies, I think that's a big space. So I'll pick one that there could be many answers to. Let's talk a little bit about carbon capture. Today, there's a lot of carbon capture going on. There's a lot of projects being started. Most of that is people taking where we have a high concentration stream of CO2 coming out of the factory or the plant and they can grab that and then put it in a pipeline and put it in the ground. And under the current policy support, at least in the United States, that more or less makes sense. Ethanol plants, fertilizer plants, those would be examples of something like that. That's going to get us started, but that's not going to get us finished, right? So my little add on where we need to really see some big technology breakthrough to get to the finish line on this is we're going to have to really work these lower concentration streams of CO2 to get the costs down. I'm sure there's technical solutions. There's ways to make molecules do what they need to do, but we got to get it where society can afford to do it. And that's going to unleash huge potential in decarbonization or in lowering greenhouse gas emissions. So think of all the coal-fired power plants or gas-fired power plants in the United States right now. Those are all low concentration, few percent CO2 going into the atmosphere. Really expensive to try to get our arms around how to capture that, to grab it, to put it in the ground. That's going to be a technology game. So that's future technology workers, people kind of working from grants like this.
And so maybe a response to that, though, is that might be a high temperature membrane that allows you to scrub the CO2 out of an exhaust stream and put it in a tank.
Could be a whole new approach I suspect it'll be a whole new approach to get the cost down. So that's kind of where I am on that first example. Your second example, this is a little bit more just Erik Oswald talking, but there's a huge demand for traditional oil and gas products, and we haven't seen that roll over. And I think there's an open question about how we're going to deal with that technologically, because there's also a huge opportunity to pull CO2 out of the atmosphere. And there's a lot of progress being made by a number of companies on a diverse set of technologies, to work on that problem. So the question for society is, how do you work that problem at the lowest cost? Because people aren't going to work on the energy transition if they don't have affordable energy, in their homes. When the lights go out, people are concerned with the lights going out. So how we work that and that technology race of like which technology wins? Is it direct air capture that's helping us mitigate places where we are going to use hydrocarbons in new ways, or are we going to build new types of hydrocarbons that are like sustainable aviation fuels, products that have a low CI signature, a low carbon intensity signature? I don't know. That's out in the future, and I think that's where we want all the scientists we can get working on the problem, and we just figure out how to solve the problem at the lowest possible cost to society, so we can work the decarbonization.
Thanks, Erik. Dai, do you have a response on that?
Yeah, just to add on, that talks a lot about the technology, how fast we can actually deploy, and then most importantly, make it affordable. I think the other area is how society can actually help. And when I think about how all these technology looks at different feedstocks and sustainable feedstocks, and we look at essentially what are we doing with waste? How are we capturing more waste and utilizing that into a more usable product? And I look at myself, and I think we look at ourselves as a whole state. Our ability to recycle and then use that as a potential, essentially as a feedstock, is certainly an area that society needs to all work together to help. And then once you do that, it's really how fast we can share the technology from which we can deploy and then make it affordable. Because if we're not going to make it affordable, I think everybody sits in this room, we're not going to essentially make it very feasible for everyone to adopt and make everybody participate from it.
Wonderful. Thanks, Dai. And Nigel, anything from your guys' end?
Yeah, I'd probably say energy efficiency, and that sounds really boring, but it actually is it's included in CCUS, and it's included, I think, in producing other feedstocks. So we're bringing it back to Louisiana. So Louisiana is #1 in the US for the amount of energy consumption per capita. It produces, though, a lot of products, of course, for the US and globally. And of course, but if we want to move into doing carbon capture, capturing carbon from low emission sources like a power plant takes about 20% of the energy that the power plant would produce to capture the CO2. And that It's because of the processes that they use that have been around for 100 years nearly. And just finding new ways to do that will also make it more efficient. So your net benefit of the amount of power the power plant produces won't be penalized so much, but it will also be lower cost because the overall process is more efficient. We're using less steel, less chemicals within the process. So yeah, there's definitely some great technologies. High temperature membranes being one of those ones. I'm sure we're going to see some innovation around when we work together as in the fuel partnership. But yeah, there's energy efficiency. There's what we've got to do. We've got to be more efficient at doing it. That will knock through onto lower costs as well, and making it therefore more achievable to society to do more of it.
Wonderful. Other questions from the media who are here?
Andy, we have one on Zoom.
Okay, we have a question on Zoom. Go ahead and read that out, Christine.
This is from Wally Pierce at News 15 in Lafayette. Acadiana is heavily concentrated in oil services companies. Do you anticipate upheaval in the job market here as we transition to clean energy, or will the many thousands of workers here find ready employment in clean energy industries?
Does anyone want to take that? I can provide some context here, and then anybody that wants to answer that. I think the context here goes back to the conversation around the need for doubling our workforce in the state of Louisiana to service the energy transition needs. So we have really skilled workers across our state. Those skilled workers currently are in the oil and gas space. I don't think that those skilled workers are going to be displaced. I think those skilled workers are going to become more in demand because they understand the old system, and they'll be able to then go towards the new system. If you remember the analog phone systems to the digital phone systems, those guys that understood the analog version and were also asked to implement the digital version were in high demand. So when it comes to, are we going to be displacing and losing oil and gas jobs in the state? I don't think so. I'm going to let the industry partners, though, sort of tap into that and talk a little bit about it.
I'll go first. It's, so personally, I'm a petroleum engineer. I graduated as a petroleum engineer. I worked in oil and gas for the first 10 years of my career. But then somebody came into the room in 2005 and said, who wants to go to a partnership meeting with other oil and gas companies on carbon capture? And I was young, and I said, yes, I do. I want to learn about that. I want to understand about this new technology area. And so yeah, you have the fundamental skill sets working in oil and gas that are also needed in the energy transition. There's electrical, there's mechanical, there's chemical, there's geology still needed in the energy transition that underpins everything. So yes, you can be a part of the energy transition too.
Wonderful. Erwin, did you want to say something? Or yeah, go ahead, Erik.
Similarly, I'd view it as additive, not a transition. I think you look at our facilities here, we have a lot of people working really hard on the traditional businesses. We don't see that changing. There's a lot of exciting new opportunity in the new businesses in CCS and hydrogen. I'm a geologist by training, so there could be more geology activity and subsurface drilling activity due to CCS in Louisiana than there's been in the traditional oil and gas space for many decades. So if policy gets put in place and we get this thing rolling, that's a rebirth of an industry rather than moving from one industry to another industry.
Maybe one thing to add, I think we all were around when the internet came. And I think we were all concerned of what kind of jobs we lose from there. But did we see the kind of jobs that created with the internet? And I think that's the same situation that we have relative to, if you heard you're going to need another 250,000 jobs. Well, there's also 250,000 existing folks who will need to transition over time. So quite a lot of growth. I think the question lies as part of the workforce that we were talking about is, how are we skilling up our folks, people in moving to those new jobs? And I think when we think about what we're doing, our partnership with LSU, our partnership with, River Parish Community College is helping our folks and our community to transition to new jobs. So if people are willing to learn new skills and transition, and we have the opportunity, then certainly that's part of the transition program.
Erwin, you were going to say something then. John, I want you to be thinking about how does this impact the way you teach students for the future?
I wanted to add one comment there. I was asked the same question on a radio show, and it's a little bit ironic, but they asked me, about jobs and whether the people who have oil field jobs now would you have more jobs in the future? And I said, ironically, the best people to put carbon back in the ground are the same people who took it out. They know how to do it. So they're in a great position to do sequestration. They're in a great position with pipelines. They're in a great position for the energy transition. So, and they've all made the commitment to be carbon neutral by 2050. So.
I was going to say something very similar to what Di said there, that there's an opportunity here for us to think about not jobs going away, but the types of jobs evolving a little bit. And as those jobs evolve, there's an opportunity for thinking through reskilling and upskilling the current workforce, right? And I think that's one of the beauties of an engine like this, where you bring together a cross-section of universities, community colleges, and technical schools, so that you think through. There are degrees, there are certificate programs, there's also just the practical experiences, the lived experiences of being immersed in sort of a new tradecraft or an evolving tradecraft, right? And so I think all of that plays to what we're trying to accomplish here, not to mention attracting exciting folks who might not otherwise think about science and technology or engineering, and inspiring them to say, hey, here's a potentially a transformative moment that's taking place that you could be a part of, and you could immerse yourself into, and now take part in a STEM driven job that you might not have otherwise considered. And so I think oftentimes when we think about these types of moments and these types of transitions, there's a fear that jobs are going away. I think the panel has made a case for there are more jobs that are going to be created. There are different types of jobs that are going to net, and it's incumbent upon us to do this right by virtue of thinking about end-to-end education and workforce development, K through 12, also today's workforce, and what are we doing about today's workforce too.
Wonderful, thank you. I'd like to ask everybody just to give a warm thank you to all of our panelists. So thank you everybody for being here. We do have a small reception outside here in the hallway, some hors d'oeuvres. We'd invite you to stick around and mingle for a little bit. And we thank everybody for being here. We thank you for your attention to this. Stay tuned. Lots of things coming down this year on our NSF engine. If you haven't picked up the Advocate print paper today, go ahead and pick up a copy of the Advocate print paper today. It has a wrapper on it that outlines our NSF Engine Award and all of our partners at the table. And we're so glad you guys were here and interested in hearing what we had to share. Appreciate you.